Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 55th Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 55 is Lychrel numbers. I'm probably pronouncing that wrong. If we take 47, reverse and add, 47 plus 74 equals 121, which is palindromic. Not all numbers produce palindromes so quickly. For example, 349 plus 943 equals 1292, 1292 plus 2921 equals 4213, 4213 plus 3124 equals 7337. That is, 349 took 3 iterations to arrive at a palindrome. Although no one has proved it yet, it is thought that some numbers, like 196, never produce a palindrome. A number that never forms a palindrome through the reverse and add process is called a Lychrel number. Due to the theoretical nature of these numbers and for the purpose of this problem, we shall assume that a number is Lychrel until proven otherwise. In addition, you are given that for every number below 10,000, it will either become a palindrome in less than 50 iterations, or no one with all the computing power that exists has managed so far to map it to a palindrome. In fact, 10677 is the first number to be shown to require over 50 iterations before producing a palindrome. I'm not reading that out. 53 iterations, 28 digits. Surprisingly, there are palindromic numbers that are themselves Lychrel numbers. The first example is 4994. How many Lychrel numbers are there below 10,000? There is a little note here that they modified the wording, but I don't think that matters for us since 2007 was a very long time ago. So we come in here, make a little file. How many Lychrel numbers are there below 10,000? So we're going to go ahead and steal these 2 lines like we always do. Okay, and for the purposes of this problem, we're basically going to be doing a lot of reversing and a lot of checking for palindromes. So I don't remember whether I created something that reversed a number before, but for the purposes of this, I want to define reverse. I'm going to take a num. Right this second, I am just going to return num. Obviously, that's not going to do what we need. Is palindrome num. And then we return num is equal to reverse num. Okay, so here, what I think we want to do is digits, which is going to equal the deconstruction into an array, string num digits dot reverse return int version of dot join digits. Okay, and those 2 methods are probably the bulk of our logic here. So come down here, limit is going to be 10,001. So I can do for n in range 1 to limit and I'm just going to have a count of 0 here. And then I'm going to print the count. Okay. So new num equals n plus reverse of n. Yes? Yes. While tries, or let's see, iterations equals zero, while not is palindrome new num and iterations less than or equal to 50. New num equals new num plus reverse new num. I suppose I could just do a plus equals here, but I'm not going to this time. I'll do it here. And down here, I don't like having to do this check twice, but it's very low cost. I think that's all we need to do. That's the whole program. Let's find out. Okay, I got 9,751, which is a large number. Larger than I expected for the first 10,000 numbers. That's almost all of them. Okay, so, wrong answer. Let's take our limit down to 1001. Or actually, let's just do 101 for right this second, so that we can make sure that we're getting some correct answers. I don't want to print all of them. Well, if it's only 100 numbers, then maybe it's not so bad. Okay, so I counted the numbers that are not Lychrel numbers. Let's just go ahead and run it again. 249, which should be 10,000 minus this 9,751. Yeah, that sounds right. And is that the correct answer? Alright, yes it is. Okay, so they're obviously Sometimes you get the correct answer because, or the wrong answer because you missed something. Usually something very small. So, again, I don't love doing this check twice, but it's fine. Obviously, this took like 600ths of a second to run, maybe, or whatever. Like, it's less than a second. I am happy with the efficiency. Um, so, all we're doing here, we set up a reverse function which uses some list comprehension stuff that Python has special, reversing our digits, converting them back to a single string instead of all those things, turning it back to an int. And obviously, again, here we are using that Python feature where it can hold arbitrary large numbers in memory depending on how big your memory is. I've been relying on that pretty heavily through these problems. And then, of course, we have checking whether something is the palindrome. And we just set a limit to be 10,001 because we want to look through the first 10,000 numbers. We start with the 1 because I don't want to deal with 0. And yeah, for 1 we would do 1 plus 1, and then for each number we do similar. And while we have not found a palindrome, or we still haven't done 50 iterations, we make a new number, we count up our iterations. When we're done with this while loop, we check if something isn't a palindrome, then we up the count for the Lychrel numbers. And then we just print out the count, and that's the whole program. So, relatively easy. Obviously, I made the mistake of not including this not here when I needed to. So, the first time I ran this, I technically got the correct answer. I just had counted which ones do it instead of which ones don't. So, very, very common mistakes there. And yeah, that's it for this one. I'll catch you in the next.